at the directions and all this good stuff. And I got 3 solids, maybe 4. And I got 3 liquids, and I got some water right there. So let's take a look at, let me go and turn on my flex cam. That's what we used to call in the olden days. That was like 15 years ago. What is this? This is a document camera. Or you may have heard the term Elmo, which is the brand name. But I kind of like this better than my Elmo because I can, because it's portable. Okay. Let's see. I got my planning calendar here. What I need is some paper. What I need is my laboratory. When's this pandemic going to be over? Oh, well. And then I could have filmed it, and then you could have seen me doing it in a lab. But oh well, that's another thing for another day. All right. Looking for a good place to do this lab on. I guess we'll just do it on the paper we were writing on for the last thing. And I haven't made a space for you to turn it in, your 15.2 questions, but just save that and know that your PLT is going to ask for it anyway. So it's good to have. But also, since we did it here in VRC Chem Labs, we'll have that as one of your 3 things that we do on a day. Okay, on separate sheets of paper, draw 2 grids similar to the one below. Make each square 2 centimeters on each side. Now, if you're picky, I'd have you measure it out, but 2 centimeters is about that big, right? So if you've got 2 centimeters, each square, 2 centimeters on each side. All right, that's like 2 lines. So there's a line. How many of them are there? 1, 2, 3, 4. 4 rows. 1, 2, 3, 4. Okay. Now, I don't know if you're doing it or watching, but either way is okay. Always better to do it if you can. Because I often mess stuff up. And then maybe if I do it wrong, you'll do it right. All right, so I got two squares, 2 centimeters on each side. It's about 2 centimeters. 2 centimeters is an inch. 2.54 centimeters in an inch. So just short of an inch on either side. That's all short of an inch. Okay, so that's that. Place a reaction surface over one of the grids and place a few grains of each solid in the indicated places. All right, so the reaction surface can be a piece of plastic. It could be like an empty Ziploc bag, or if you have your kit, and I do, I got these things, right? To give myself a little bit more, I'm gonna use more room to work. I'm gonna use that one. Why am I at an angle? I know, here, it's kind of angled. Let's go like that. Okay. So there's a reaction surface. So like if you had what do you call those plastic things you put in your binder where you put a piece of paper in it and it protects it? What's that called? What's that sheet called? It's called a sheet protector. You can put it in you could use a sheet protector as a reactive surface as well. Okay, let's see, what else is there? Okay, going over here, you have place the reaction surface over one of the grids and place a few grains of each solid in the indicated places. Test each solid for conductivity. All right, which is interesting, oh, look, the way I drew it is pretty cool because I got 4x2. This is 4x2, and over here 4x2. I just got lucky. I would say I planned it that way, but I didn't. Okay, so there it is. And I put the solids in there. What are the solids again? The solids are, moving over here, salt, baking soda, what is that? Cornstarch, sugar. This one's baking soda. All right, so let's put those in there. So a little bit of salt, a couple of grains, it says. Isn't that what it said? Place a few grains in there. Oh, hang on. Hi. See, it's one of those calls. I have Verizon. You have Verizon? Oh, that one didn't even, that got past my spam blocker. So here I am with the salt. The salt goes in the first one. Okay, so I'm gonna put the salt in there, just a few grains. How many? What do they say? Just a few. Oh, I'm off camera. Okay, so I got some salt in that one right there. What's my next one? Magnesium sulfate. Now, if it's for my kid, I don't really want to like pinch it like I did the salt. Okay, that's a few grains, right? But I have to have enough so I could put the tester on it. So I got that. So that's this next one. I got the salt, and I've got salt on my table because I didn't close the Ziploc bag. I got these from the 99-cent store, and they're cheap and they don't work. All right, let's go next one. Sugar is on the right there. So second one down. Second one down, and on the second row, 2 by 2. Pinch of sugar right there. Okay, baking soda goes right here. Okay. And then what else do they say? I gotta throw those 3 over there. Did I do sucrose yet? I think I did, right? Sucrose, cornstarch, and second one, second row, third down. So here's a little bit of cornstarch / flour. I'm not sure, but it'll work. That's too much. Okay, so anyway, so I got my solids in there. I know it's a solid because I had an S after it. So the solids are oh, it's, all these are solid, aren't they? Sugar, cornstarch. Yeah, all solids, KI, KIS, and KCl. Oh, here's a K. This is, in our kit, we got liquid KI. Okay. So I don't know if that's going to work. We'll see. All right, let's go to instructions right here. It says, separate sheets of paper, draw 2 grids. We did that. Place the reaction surface over to one of the grids and place a few grains of each solid in the indicated space places. Test each solid for conductivity. Add a drop of water each solid. Test the wet mixture for conductivity. Be sure to clean and dry the conductivity leads between each test. Okay, so we're checking for conductivity of these solids. And so we don't have, how many we have? 1, 2, 3, 4, 5 solids. All right. I got to go to my kit and get a dropper. So I got a dropper, and how much water? They say add 1 drop of water to each solid. That's kind of like, I don't know, 1 drop's going to do it. So here we go. Whatever it is, it might be 5 drops, you know. Whatever I put in this one, I'll just put it and make them all the same. So it's 1. Is 1 enough? No. 2, 3. That's probably pretty good. So I got 3 in the salt. So I'm gonna put 3 in all of them. So let's go. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. All right. If I tilt it, this will work. Okay. But if I don't tilt it, will I get enough contact? Let's see. So I've got my conductivity tester going. Is the recording on? It is. And I'm going to move myself so I can get a shadow. Sorry, dog. And let's see what we get. For the first one with salt, let's go. Did you see it? Oh, you can't even see the light. Okay. So there's the light. Let's try salt. NaCl. Watch the light right here. Yep. Okay. So that works. So that's pretty cool. All right. Let me get a washing bead. Get some water and wash this off. Ideally, what you would do in the laboratory is you would have your squirter bottle like this, right? You have one of these. I tend to not like these because as they sit with the water pressure, sometimes they start leaking out the tip. And so the ones I have in my lab room, we tilt kind of up. This one tilted downward. So you can't really change it on this one. So there's that. And then I'm going to take my conductivity tester and then rinse it off with distilled water like that. Okay. And even when I'm not using it, you should keep it in there or keep it totally dry. Okay. So that's it for, oh gosh, just spilled it on my paper. Oh well. Let me get a paper towel and see if I can save some of the paper. Not the first spill I've made today, or this week anyway. My wife said I no longer can drink a drink in the TV room without a lid. Because if I don't knock it over, the dog knocks it over or the baby knocks it over. So I've got my Diet Pepsi and one of these puppies. I need a refill. Okay. So salt does dissociate into electrolytes, and our conductivity meter shows a red light, and so that seems to be making ions and conducting electricity. Let's do the second one. Again, watch the light. And what is this chemical? The second chemical is magnesium sulfate. Does the magnesium sulfate dissociate and form electrolytes? What's your guess? Do you think so? I think so. Okay, so let's go. Oh, let's move this back. Whoops, there goes. So red light on that one also. So let me rinse off my electrolyte. I'm off screen doing it, but trust that I'm doing it. Or no, don't trust that I'm doing it. Watch me do it. There it is right there. I'm going to rinse it off. Okay. Third one is what? Okay. Third one is sugar. Now, from what we just did in 2.1, do we expect the sugar to light up? Do we expect it to dissolve or dissociate in water? Is it ionic or is it polar covalent molecule? And so considering those things, I'm going to put this in here and I know what to expect. Well, let's see what we get. Do you see anything? Can you see anything at all? Here, I'm going to go closer because you got to. And this makes sense according to what we just did in 2.1. All right, it's hard to focus on this one. Ooh, all right. Can you see? I'm not touching it at the moment. We're trying to watch this red bulb. And here I go. I'm going to touch it right now. Lights up. So that's the sugar. Did it light up like the salt did? No, but it did light up. And that makes sense because remember, although it's not ionic, it is covalent. But even though it's covalent, it's polar. So we do expect some type of reaction, even possibly a lesser reaction, and we did. Okay, the next one is baking soda. Baking soda is NaHCO3. And if you remember from what we just did, that dissociates into sodium and the hydrogen carbonate. So let's pan out just a little bit. And I'm going to touch the electrodes to this one right here, which has the baking soda. So let's do that. Here we go. Watch the light though. Ready, set, go. Okay. Pretty good reaction there. And then the last one we have that's a solid. Well, these are liquids, so that's not going to work. Or maybe, let's try it. Okay, the last one that really counts, and I just made another spill, is this one right here with the cornstarch. But hopefully, well, I don't know. Do we expect cornstarch to dissociate into ions? Do we think that cornstarch is a polar covalent molecule? Well, considering those, let's go ahead and just touch it and see what we get. Okay, there's the light. It is not lit at this point. Let's touch it, and it does light up just a little bit. You see it? Okay, so positive. Now, the other thing that I thought we had, and then it's like, oh, it says solid, is Ki right here. Wait, you can't see that. Right here, Ki. And we have some Ki in our kit, but it's already in solution. So this is mostly water with 0.1 molar potassium iodide. So I'm going to put a few drops of this in here, enough to test. Okay, I'm going to take my electrode and rinse that off one more time. Okay, and then let's try that. Here it is. It is. I'm kind of in the sun now, so that's what it looks like unlit. And ooh, pretty strong reaction, right? So that's your potassium iodide aqueous solution. Aqueous meaning that it's in water. All right, so everything lights up pretty well. Yay. And then, oh gosh, that's a procedure. That's all you need. So now you have everything you need in order to answer these questions. So to finish up, I'll have you write up a lab report, but just remember, it's like always, no tricks or anything. You need a cover sheet with some kind of photo. You could do a photo of a lab setup or something like that. If you did it with me, you can, I don't know, you want to take a screenshot of something like the electrodes and the magnesium sulfate or something like that. You know, you could work something. And then remember after that, you have 4 parts of the lab report. Those 4 parts are the introduction, and you could write a few sentences about what's happening here. After that, there's the materials and methods. I would go ahead and take a picture of 508 and call that materials and methods. because that's what that section is right here. The third section is the results. The results are going to be this table right here, but we saw that everything lit up. So all of these guys, we did these 5, plus we did this. We didn't do these 2 because we didn't have them, but we did these 6. All right, 1, 2, 3, 4, 5, 6. Did not do those 2. So if I had a pencil, I'd put an X here and an X here. Or you can write in your book, you know, X and X. But all of these lit up. This one, not as much as the other ones, but they did all light and show conductivity. Okay, and then the last section is your result or your discussion section. In your discussion section, I'd like you to answer the analyze and conclude questions. And then over here, let's take a quick look at this. Number 1's okay. Number 2, let's see. 2 and 3 tell you to do other stuff. So let's skip the design and experiment, and let's just go 1, 2, 3, 4, 1. And then if you would please, a concluding paragraph as well. I'll write this all up and I'll put it in Canvas, but you already know what I'm going to write because I just told you, and it's the same as what we usually do. Okay, so thing number 1 today, we just did 15.2. Thing number 2 today, we did this lab and got some decent results compared to what I sometimes get when I'm out here with this little kit, right? And then the third thing is